The pressure changes are a fundamental factor for the understanding of marine weather. The barometer is an ancient instrument. Think, for instance, of Guy de Maupassant, who in the middle of the 19th century on board his Belle Amie used to sail along the coast of the Mediterranean, calling even at Portofino. On board the Belle Amie, the crew was made up of two people, Captain Bernard and Raymond. They had quite a different approach to sailing. Bernard was always worried just at the sight of a small cloud or a ripple of the sea surface. He expected a thunderstorm to develop. On the other hand, Raymond was more used to the weather changes and used to say, when the wind strengthens, we will lower the sails. And then there was on board a third mute member of the crew. It was the barometer. Nowadays, like in the past, the pressure changes are extremely important to understand whether the wind is going to pick up, and the result of this, the sea to increase and the weather to change. We've mentioned the high and low pressure areas. Let's try now to see how the areas of high and low pressure develop over the Earth's surface. And to do this, we have to talk about the energy that the Sun transfers to the Earth's surface. The Sun's heat penetrates easily through the Earth's atmosphere, but the Earth's surface, either on the mainland or sea, absorbs the heat that is then returned to the layer of air immediately close to the ground, triggering the so-called connective cells. The lighter hot air tends to cool as it rises. Then, as it gradually cools down, it tends to descend again. That's how the connective motion develops. In practice, this is the origin of the various meteorological phenomena we can encounter during our navigation. In this respect, it's important to bear in mind that the hot air is lighter and the cold air is heavier, and the barometer is the instrument measuring the weight of the air. Pressure varies in relation to the two factors, the air temperature and the altitude. This is an aspect only relatively important to us, but it's good to be aware of it. For example, two people standing on the beach would bear the same weight of the column of air above them. If one of them would position higher up, the pressure and the height of the air column would tend to decrease. Logical to say. The atmospheric pressure decreases as the altitude increases. This is an element mountaineers are very aware of. In fact, they always use the altimeter, which works on the same principle of the barometer to determine the differences of their climbings. Therefore, the barometer behaves exactly like a scale, which measures the weight of the air. With the heavier cold air, the pressure goes up. With the lighter warm air, the pressure comes down. The barometer will enable us to find out whether we can expect a mass of cold air or one of warm air to approach. To understand the behavior of the wind in relation to the pressure changes, we can compare wind with water. They are two different types of fluid with some similarity in their movements. In this case, for example, this container filled with water has a higher pressure at its bottom. In the same way, the pressure is higher at ground level. They are used to determine the synoptic situation, which makes it possible for us to read the weather charts. How do we get a synoptic chart? We have to draw lines joining the points of equal pressure. You see here, the pressure is 1016, 1012, 1008 and 1004, and the forecaster draws a line joining the points with the same pressure. In this way, we get a synoptic situation, which highlights the area of low pressure or high pressure. Nowadays, all this is done in a computerized way, but in the past, it was the forecaster that used to transfer the pressure values received by hand and determine the synoptic situation with his own pencil.